Welcome to the Young Minds of Food Safety podcast, where science is in our DNA. Join us as young scientists from the Food Safety for EU project share cutting-edge research and innovations shaping a safer, more sustainable food system. Hosted by LVA.
In recent years, the push for more sustainable food production methods has led to some surprising innovations. One of the most promising ideas involves using insects, specifically black soldier fly larvae, to recycle food waste. These larvae not only help reduce waste, but can also bioremediate harmful pollutants, turning food scraps into valuable products. However, this novel approach is not without its challenges, particularly when it comes to food safety. The European Union has strict regulations that prohibit using food waste containing ruminant proteins as a substrate for insect farming due to concerns about contamination risks. Today's guest, Joana Oliveira, is working on the cutting edge of this field. Her PhD research focuses on assessing these safety risks through microbiological and chemical analysis and developing strategies to ensure that insect-based food systems are both safe and sustainable. Joana's work could hold the key to making insect farming a central part of our circular economy while maintaining the highest standards of food safety. In this episode, we will explore the exciting potential of black soldier fly larvae, the challenges they face, and how the science behind them could change the future of food production. Welcome, Joana. It's really nice to have you here on the show today.
Thank you so much for having me today.
So, Joana, as a fast warm-up question, if a black soldier fly larvae had a slogan to promote their role in food waste recycling, what do you think would it be?
Well, I always say tiny creatures with big impact. I think it's the best slogan for them.
That's a perfect slogan, I think, yes. Coming now to a more serious note, the circular economy and insect-based food production seem like a perfect fit, right? So can you explain how black soldier fly larvae, or also BSFL, are contributing to the recycling of food waste and what makes them so efficient in this process?
Yeah, well, black soldier fly larvae, or BSFL, are a perfect fit for the concept of a circular economy, which is all about keeping resources in use for as long as possible and turning old products back into something valuable. So they are incredible little recyclers, actually. They thrive on decaying organic matter, things like food waste, agricultural byproducts, slaughterhouse byproducts, and even some types of animal manure. And then instead of letting these materials ending up in landfills or being incinerated, BSFL can actually consume them, break them down, and convert them into something useful. So because the larvae themselves become a rich source of protein, which can then be used in animal feed for swine, poultry, and also for farmed fish, so aquaculture. And what makes them so efficient is their digestive system. They have got some specialized enzymes that allow them to break down materials that would otherwise take a long time to decompose. And that's not all, because as they feed and they grow, they also produce frass, which is basically their feces. And the interesting part is that this frass is actually an organic fertilizer. It's rich in nutrients that are great for plants. So instead of using synthetic fertilizers that have a heavy environmental impact, we can use BSFL frass to nourish crops in a much more sustainable way. So I think that, just to wrap up, by recycling food waste and turning it into something valuable like animal feed and fertilizer, BSFL help close this loop in our food system. So they are reducing waste and providing resources for agriculture and contributing to a more sustainable way of feeding the world.
Yeah, that sounds very promising. And could you maybe also elaborate on the environmental impact of using this larvae in food production systems compared to traditional waste disposal methods?
Regarding that, recent studies show that BSFL treatment outperforms traditional waste disposal methods like landfills, composting, and incineration on key environmental impact indicators, because BSFL produce fewer greenhouse gas emissions, occupy less land, and contribute to lower terrestrial ecotoxicity. And their production also uses less non-renewable energy. And apart from that, BSFL can remove or reduce to acceptable levels certain contaminants that are present in the waste they process, making them a safer and more sustainable option for food waste management.
Mm-hmm. Yeah, that's also very interesting. And Joana, despite the potential benefits, there are regulatory challenges, especially in the European Union, where food waste can't be used as a substrate for insect farming due to the contamination risk. How do these regulations impact your research and the broader adoption of BSFL in food systems?
Well, yes, unfortunately, despite this whole potential of BSFL as food waste management, there are some regulatory challenges, particularly here in the European Union, that present some barriers to using food waste as a substrate for insect farming because of contamination risks with pathogens like bacteria or prions. Prions cause encephalopathies, spongiform encephalopathies like the mad cow disease, and also with some chemicals. And these regulations impact my research because I have to carefully handle the different substrates. For example, I cannot use food waste in the same space where bioconversion, the normal bioconversion process, which means the production of insects for feed, is taking place. And any product derived from food waste, which means BSFL protein meals derived from BSFL reared on food waste cannot enter the agri-food chain. Instead, these materials will then be used for other specific experiments. Regarding the broader adoption of BSFL in food systems, these regulations slow down the integration of BSFL into waste management practices, and overcoming these challenges will require further research to demonstrate that food waste can be safely used as an insect substrate, which could eventually ease these regulatory restrictions. And we remain hopeful that these restrictions will be eased in the near future.
Yeah, let's hope that. And what steps are you actually taking in your research to ensure that these regulations are met while still promoting the use of food waste in insect farming?
Okay, so my research actually focuses on exploring safe ways to process food waste for BSFL. And to do that, first I ensure that any food waste used in my experiments is carefully controlled to avoid contamination risks. And this involves strict separation from other substrates and ensuring that the waste does not come into direct contact with the agri-food chain. And additionally, I am studying the food safety of the final BSFL products, such as BSF protein meal, to ensure that they meet the safety standards for use in animal feed. And I am also exploring the potential of BSFL as a bioremediation tool, as they can break down and reduce contaminants in the food waste, making it safer for use in the production process. And to further enhance safety, I am actually developing a transgenic line of BSFL that is fluorescent for the traceability of the entire process, to provide greater control throughout the production process. And then in terms of overall risk management, I will conduct a detailed risk assessment of this bioconversion process of food waste. And then based on this assessment, I can implement targeted risk mitigation strategies to ensure that this process is as safe as possible and complies with regulatory standards.
That's very interesting. And Joana, you mentioned it already that the focus of your work is all about assessing the safety of insect-based food systems, particularly through microbiological and chemical analysis. So what are the key contaminants you are investigating and how do they pose a risk to food safety?
Well, regarding microbiology, I study pathogens such as Salmonella, E. coli, Listeria, Bacillus cereus, and Vibrio. And these bacteria can cause foodborne illnesses if they persist in the larvae and are not effectively reduced or removed during processing. And additionally, I monitor indicators of hygiene and spoilage to assess the overall microbial quality of the system. I also investigate fungi, including molds that can produce mycotoxins, as well as histamine, which can accumulate in the substrates and larvae and cause foodborne illnesses if present at high levels. Regarding the chemicals, I investigate metals and metalloids like lead, cadmium, and arsenic, as well as pesticide residues and mycotoxins, which may accumulate from contaminated substrates, and these contaminants can pose chronic health risks if they transfer into the larvae or the derived products, which are the BSF protein meal, and making this regular monitoring essential.
And how can we be certain that these contaminants do not end up in the food chain, particularly when BSFL are used in animal feed or human food products?
Well, currently, black soldier fly larvae are only authorized for use in animal feed within the European Union, and they are not yet approved for direct human consumption. So, this regulatory framework already reduces the likelihood of contaminants entering directly the human food chain, because, of course, then we have the part of animal feed, and some of these animals will feed people. And in that part, to ensure safety regarding these animal feed, strict quality control measures are applied throughout the production process. For example, the substrates that are used to rear BSFL must meet high safety standards and are only approved feed materials, such as vegetable byproducts. And this prevents potential contamination from unsafe waste streams. And in addition, the larvae undergo processing methods such as drying and defatting, which significantly reduce microbial and chemical risks. And as I said before, my research also investigates the ability that BSFL have to reduce or remove pathogens and degrading certain toxins as part of their natural feeding and digestion process. And then, of course, monitoring does not stop here at the production stage. The final products that are derived from BSFL, such as protein meals and oils, should be tested for contaminants, including pathogens, metals, and pesticide residues before being approved for feed. And regular monitoring ensures compliance with European regulations and provides an additional layer of protection, of course. And while current authorizations are limited to feed, ongoing research, including my own, aims to build a strong evidence for expanding the use of food waste as an insect substrate, and also expanding the use of BSFL into human human food applications in the future. And of course, this involves risk assessments and the development of safety measures to support this regulatory approval for broader applications.
Yeah, it sounds like that there is still a lot of work to do, but it's definitely a very important part for the future, I would say, to get into a more circular economy. And Joana, you have presented the results of your research last year at the Food Safety Forum in Rome. And preliminary results from your research show that BSFL can bioremediate foodborne pathogens like Salmonella, Bacillus cereus, and Vibrio species, like you mentioned. So how does this process work, and can BSFL really reduce the risks associated with these pathogens in food systems?
Well, yes, preliminary results from my research indicate that the BSFL have this promising bioremediation potential. And this process works through a combination of biological and environmental factors, because BSFL produce antimicrobial peptides, which are a natural compound that actively target and suppress bacteria. And my findings show that pathogen loads can be reduced to levels considered safe by regulatory standards, particularly when combined with post-processing treatments like drying and defatting. However, while these results are actually encouraging, it's important to continue evaluating this bioremediation capacity under different conditions and substrates to ensure consistency and safety across diverse applications. And just to wrap up, these abilities highlight BSFL as not only efficient converters of organic waste, but also as contributors to safer and more sustainable food systems.
This is indeed a very promising research you're focusing on, but now I'm curious, are there any limitations to this bioremediation process that we should be aware of in terms of the pathogen control?
So, firstly, while BSFL have shown the ability to reduce pathogen loads, the efficiency of this process, of course, can vary depending on the type of substrate used, the initial contamination levels, and also the environmental conditions such as temperature, moisture, and pH. For example, heavily contaminated substrates may require additional processing steps to meet safety standards. And we cannot forget that certain pathogens like Bacillus cereus form heat-resistant spores that may survive digestion by the larvae and persist not only in the larvae but also in the resulting frass. So this means that further treatment like heat processing with very high temperatures might still be necessary to ensure complete pathogen elimination.
Perfect. So, Joana, we are already coming to an end of this episode today. And when we're looking forward to the future, what are the next steps in your research, and how do you envision the role of BSFL in the sustainable food systems of tomorrow? What impact do you hope your work will have on the future of food safety?
Looking ahead, the next steps in my research focus on conducting a detailed risk assessment of BSFL reared on food waste, identifying potential hazards, and developing effective risk mitigation strategies. And a key part of this work involves evaluating the safety of, as I said before, the final products, such as BSFL-derived protein meals, and testing innovative approaches like a transgenic line of BSFL that is fluorescent, and this line could improve traceability and monitoring, providing an additional layer of safety assurance. In the long term, I envision BSFL playing a key role in sustainable food systems by closing nutrient loops, reducing food waste, and lowering the environmental footprint of food production. And their ability to upcycle organic waste into high-quality protein and fertilizer fits perfectly within the circular economy models, as I said before, helping to address global challenges like food security and waste management. And while BSFL are already approved for feed, the challenge lies in demonstrating that food waste can be safe and sustainable input for their production. And I aim to provide the scientific evidence needed to support regulatory changes that allow food waste to be safely incorporated into circular economy systems. And ultimately, I want to contribute to making food production safer, more sustainable, and more resilient in the face of future challenges.
Sounds great to me, and you have a lot, actually a big list of great goals, and I really hope that you can achieve all of these goals. I come now to my final question, and it's probably the most difficult to answer. How can food safety experts, regulatory bodies, and industry stakeholders collaborate to accelerate the safe integration of insects into food systems?
Well, I think that collaboration between food safety experts, regulatory bodies, and industry stakeholders is essential for the safe integration of insects into food systems, because food safety experts will generate critical data through risk assessments, helping to identify hazards, particularly when insects are raised on food waste. And this evidence supports the creation of safety standards. And then, regulatory bodies must collaborate with researchers to update regulations, ensuring they reflect the latest science and safely incorporate food waste as a substrate. And proactive monitoring and revisions will help ease concerns about contaminants. And then we have the industry stakeholders that play a key role by adopting best practices, investing in safety technologies, and ensuring compliance with regulations. And their collaboration with regulators and researchers fosters innovation while maintaining safety. So I think that together, this multidisciplinary approach will create a safer, more efficient pathway for integrating insects into food systems, ultimately speeding up the adoption of insect-based solutions for food waste recycling and sustainable protein production.
Yeah, Joana, thank you for sharing your fascinating research with us today. I think it's clear that the potential of black soldier fly larvae in food waste recycling and sustainable food production is immense, but as we have discussed, ensuring food safety is key to its successful integration. So your work on assessing and mitigating risks, as well as developing safe practices, is paving the way for a more sustainable future. And it's really exciting to think about how innovations like these can contribute to a circular economy without compromising food safety. As always, I think it's important to remember that with the right science and rigorous safety standards, especially in Europe, we can continue to lead the way in both innovation and food security. So thanks again for being part of the Young Minds of Food Safety podcast, and we look forward to seeing how your work will progress in the future. Thank you.
Thank you so much for having me again.
Thank you for tuning in to our podcast, Young Minds of Food Safety. If you enjoyed this episode, make sure to subscribe to our YouTube channel so you never miss out on the latest insights from the brightest young minds in food safety. For more information and to stay updated on the Food Safety 4 EU project, visit our website at www.foodsafety4.eu. We'll see you in the next episode.